do problems on Lagrange mean value theorem. Question. The first question is fx equal to x square minus 2x plus 4 in the interval 1 to 5. We have to verify Lagrange mean value theorem. Verify LMVT, Lagrange mean value theorem. So first, fx is a polynomial. The first thing is fx is polynomial. The first thing we are seeing, fx is a polynomial. Fx is polynomial, so continuous on one close interval 1 5. The first point. The second point, f dash x, fx is derivable, on open interval 1 and 5. Now there exists a c between 1 and 5 such that f dash c is equal to f5 minus f1 and by 5 minus 1. So we need to find f5. हमको f5 निकालना है. f5 is 5 square minus 2 into 5 plus 4, 25 minus 10 plus 4, that is your 25 minus 10 is 15, 15 plus 4 is 19. And f of 1 is 1 square minus 2 into 1 plus 4. This is 1 minus 2 plus 4, that is minus 1, 3. Very simple. Now let's put the values. Let us now put the values here. Yes, wait a minute. Yes, here we will put the values. Wait, let me take that picture. Let me take this. Yes, I have to put the value here. Now, f dash c is, wait a minute, f dash c is 19 minus 3 by 5 minus 1. That is 16 by 4. That comes out to be 4. So, and 4 belongs to open interval 1 and 5. So, LMVT is verified. Suppose I had got a value 6 or less than 1, then this wouldn't have lied between 1 and 5, and so LMVT would not have been verified. Listen again. Suppose instead of 4, I got 5 or I got 0.5, then this quantity, I get 6, 5 or greater than 5, whatever, 6 or whatever, then this won't lie between 1 and 5. This value will not lie between 1 and 5. In that case, LMVT is not verified. अगर मुझे वैल्यू 4 से कुछ और मिलता, सपोज 6 या 5.5 या कुछ मिलता, 5 भी मिलता और 0.5 भी मिलता या 1 भी मिलता, तो ना तो 1 यहाँ बिलोंग करता है ना 5 बिलोंग करता है, तो फिर उस समय LMVT वेरीफाइड नहीं होता. आई होप यू हैव अंडरस्टूड. Now another problem. Let us take another problem. This problem. Let us take this problem. Question. Fx is equal to mod x for x belonging to -1 and 1. Verify LMVT. Very simple. First point. Fx is a modulus function, and you know the graph of this. You know what is mod x. You know the graph of this, like this, at 0. So the modulus function, mu. Modulus function, modulus function. So it is CTS, continuous, on -1 to 1. Now for the second point, you need to understand that. You need to find f dash c. Fx is mod x. Mod x means x for x greater than or equal to 0 and minus x for x less than 0. If this is the situation, then you see RHD, right hand derivative of f dash 0 plus, you need to find at the disconnecting points. So f dash 0 is limit x tending to 0 plus fx minus f of 0. At f of 0, you will take this value of the function, and f at 0 is 0 always. So upon x minus 0, that is nothing but limit x tending to 0, limit, wait a minute, let me write it properly. This is limit x tending to 0 plus fx is x because it is greater than 0 upon x, cancel out, you get 1. And LHD, left hand derivative, f dash 0 minus is equal to limit x tending to 0 minus fx minus f of 0 upon x minus 0. This is limit x tending to 0 minus less than 0. You will take this part of the function minus x upon x, and then you will get, wait a minute, you will get, this is minus x upon x, so you will get minus 1. So both of them are not same, this and these are not same, as as f dash 0 plus is not equal to f dash 0 minus. So f dash 0 0 does not does not exist, and so fx is not derivable derivable at, or derivable on, rather on derivable on open interval 1 and minus 1. See, 0 belongs to 1 and minus 1, and in 0 it is not differentiable, so it is not so this is not, so fx does not does not verify verify LMVT for any point. Suppose it is not 0, some other point also. I'm taking in case general case. So for any function, if a for a single point, if the function is not differentiable at that point, the LMVT will not be verified. अगर कोई भी function ले लो इसको छोड़ के, other than this function you take any other function, and if for in some point between that interval, if that function is not differentiable, then that LMVT is not verified. So in this case 0 minus 1 1 के बीच में है, तो ये 0 पॉइंट पे ये डिफरेंशिएबल नहीं है, तो एलएमवीटी सेटिस्फाई नहीं करेगा, एलएमवीटी वेरीफाई नहीं होगा. कोई भी फंक्शन ले लो और कोई भी एक पॉइंट अगर किसी इंटरवल में उस वहां पे उसकी वो डिफरेंशिएबल ना हो, तो एलएमवीटी वेरीफाई नहीं होगा. कोई भी फंक्शन ले लो, कोई भी दूसरा फंक्शन, और कोई भी पॉइंट ले लो किसी भी इंटरवल के बीच में, उस पॉइंट में अगर फंक्शन डिफरेंशिएबल नहीं है, तो इसके मतलब एलएमवीटी नहीं होगा. दैट्स द पॉइंट. नाउ लेट अस टेक अनदर क्वेश्चन. Now question is, this is a good question, take this. Verify LMVT on fx e to the power of x on in the interval 0 1. Now fx is exponential, so continuous on 0 1, closed interval 0 1 first. Second, fx is derivable on open interval 0 1. There exists a point C belonging to in between 0 and 1 such that f dash C is equal to f of 1 minus f of 0 upon 1 minus 0. So this is nothing but, see, fx is what? Fx is e to the power of x. The derivative of this is e to the power of x only, and f of 0 will be e to the power of 0, that is 1, and f of 1 is e to the power of 1, that is nothing but e. Got it? So f dash c means e to the power of c is equal to, what is f of 1? What is f of 1? That is e. What is f of 0? That is 1 minus 1 upon 1. That is nothing but e minus 1. Now see one thing. एक चीज देखो, E is actually 2.712 something like that. E lies between E lies between 2 and 3. 2 and 3. Can you see this E's value? This is the approximate value of E. Now, this is of the form E minus 1. So subtract 1 on all sides. Subtract, next line, in the next line I will do it. So 2 minus 1 less than E minus 1, subtract 3 minus 1. So this gives me 1 E minus 1 less than 2. And what is E minus 1? It is nothing but C. And this is, what is this? C, e to the power of C. It is nothing but e to the power of C. Wait a minute. It is nothing but e to the power of C. This is e to the power of C. So 1 less than e to the power of C less than 2. Take log on both all sides. Taking log 1 is log EC is log 2. And remember one thing, log AB, extremely sorry. Log a to the power of m is m log a, and remember one thing, log a base a number a is always 1. This is a known fact. So what you do is that write this as log 1 is 0. So this is a to the power of m, c log e log 2. Now this is log 2. Now you see one thing, log EE will behave like this. So this will be 0 C log 2. And log 2 has a value of, I think, 0. Wait a minute. Log 2 has a value of 0.693. And log base 10 2, don't confuse with this. Base 10 2 has 0.3010. This is, whenever we write log, we always talk about this is same as log base E2. Remember this. This is natural log. Until and unless otherwise stated. समझने की कोशिश करो. log 2 जो यहाँ लिखा हुआ है वो एक्चुअली log base E2 है, नेचुरल लॉग. उसकी वैल्यू होती है 0.693 और log 10 base 2 की वैल्यू होती है. हम लोग जो log यहाँ पे लिखते हैं वो log नेचुरल लॉग की बात करते हैं हम लोग. Always. We always talk of natural log. That's the main thing. Let us do one more question. Let us do one more question on this. I have to using LMVT show that mod sin x minus sin y is less than mod and equal to x minus y for all x comma y belonging to real line. This is the thing. Now you take, how to take the function. See, this is a sine function test. So you take fx equal to sin x. The first point. How to do this? Answer. Now, 1. Sin x is a continuous function, being a trigonometric function. Sin fx is continuous on any interval you take, x comma y, where this x comma y belong to R. Now, second, fx is derivable, sin x is derivable, the derivative of sin x is cos x on open interval x comma y. There exists a point C. Let me put it here like this. Okay, like this would be okay. There exists a point C belonging to x comma y such that f dash C is equal to fx, fy minus fx, fy minus fx, because y is greater than x, upon y minus x. Now what is fx? Fx is sin x. What is f dash x? That is cos x. What is f of y? F of y is nothing but sin y. And of course, you know f of x is sin x. Therefore, let's take some page. Therefore, this still here. Therefore, f dash c means, here you put cos c is equal to f of y. F of y means sin y, sin y minus sin x upon y minus x. Now I have to show, see, I have already this. Wait a minute, let me rub this and write it properly. Cos c, this is cos c. Now I already have this. See, I already have this thing here. Now I know I use this to find this. Now the thing is this, I have to show this thing. Mod of this is this. I have to show this thing. I have to show sin x, sin by mod is this. So what I'll do is that I'll see one thing. Let me tell you one thing. Sin x is always between my plus 1 and minus 1. Cos x is also between plus 1 and minus 1 equal to. So mod, let me write it here. Mod sin x is between greater than 0, greater than equal to 0, less than 1, less than equal to 1. Similarly, cos mod is greater than equal to 0, less than 1. So I'm taking this condition, these two parts. So mod, take mod on both sides. Cos c mod is take the mod sin y minus sin x upon y minus x whole mod. You know that a by b mod, a by whole mod is a mod by b mod. So you can write this as mod sin y minus sin x upon mod y minus x. And inside mod, a minus b mod is same as b minus a mod. Wait a minute, let me write down the concept. A minus b mod is, a minus b mod is same as b minus a mod. Therefore, just a minute. Therefore, therefore, this this cos c mod is equal to sin x minus sin y mod upon x minus y mod. Now, see this. Now, cos c mod is using this condition less than equal to 1. So for put what is cos c, mod cos c, this quantity. So now you have this. Yes, you have this. You keep it this. So this mod cos c is this and mod cos c is this. Therefore, sin x minus sin y mod upon x minus y mod is less than equal to 1 implies cross multiply sin x minus sin y mod is less than equal to mod x y. Mod x y. This was supposed to be proved.